Prism has a base and an apex. It has two refracting sides that meet at the apex, forming an apical angle, and has two parallel sides. Here we have a prism. On the left side there are two red pens fixed along a line that represent an incident ray. The angle of incidence is 60 degrees. Now we fix two yellow pens in such a way that line joining them is continuous to reach the image seen of the two red pens as seen through the prism. Now we remove the prism, the pens, and we can draw the emergent ray. Rays coming from an object will fall on the side of the prism, will undergo refraction, then will emerge out of the prism. As you notice, rays are deviated toward the base of the prism. So we have an incident ray, refracted ray, and emerging ray. If an eye receives these rays, an image will be perceived in a location toward the apex of the prism. You notice with prisms, rays are shifted toward the base, and image is seen shifted toward the apex. If you see a line through a prism, part of the line seen through the prism will be seen shifted toward the apex of the prism. If there is no prism, rays would continue on this path. Amount of deviation seen between the original path and the emerging rays. This is known as the angle of deviation. If the angle of incidence is gradually increased, the amount of deviation will gradually decrease to a certain amount, after which it will increase again. In this graph, on this line, this is the angle of incidence and this is the angle of deviation. If the angle of incidence is gradually increased, the angle of deviation will be less till reaching one level, then it will increase again. This angle of incidence that will show minimal deviation, we call this angle of incidence the angle of minimal deviation. When the deviation is minimal, two characteristic things appear. First, refraction is usually symmetrical. That's to say, the angle of incidence equal to the angle of emergence. Second, the angle of deviation is half the apical angle. Here, angle of deviation is half the apical angle. A refraction of a prism depends on the refractive index. In ophthalmology, prisms are made of crown glass. Second, the apical angle of the prism. Third, angle of incidence of rays. We can neglect this factor in ophthalmology. There are 4 methods used for the nomenclature of a prism. The first is prism diopter. One prism diopter is the power of a prism that causes shift of 1 centimeter on a flat surface located 1 meter from the prism. So this is the prism, away 1 meter, have a flat surface here. A prism that causes a shift of 1 centimeter, we call this is the unit, and this is the prism diopter. Prism diopter is the method used in the trial lens case in ophthalmology. The second method is the centrode. One centrode, it is the prism of a power that causes shift of an image of 1 centimeter, but along a curved surface on a distance of 1 meter. As you can see here, being curved surface, the distance is always fixed from the prism to the surface, which is not the case with the flat surface in the prism diopter. So centrode is more accurate. But in ophthalmology, we can use prism diopters and it's still accurate because we are using low power prism. The third method is apical angle in degrees. We say that we have a 10-degree prism, 20 degrees prism, and so on. Lastly, the angle of minimal deviation in degrees. As we said before, the minimal deviation equals half of the apical angle. So we have 4 different methods for the nomenclature of a prism. Now, prisms cause a phenomenon known as dispersion. If narrow beam of white light is allowed to fall on one side of the refractive surfaces of the prism, light will come out on the other side and will be split into 7 colors. The splitting of light to its component colors is known as dispersion of light. And these bands are known as the spectrum. To understand this, we know that visible light is formed of mixture of waves of different wavelengths. This will be discussed in details later in physical optics. Short waves are characterized of having high frequency, while long waves are characterized of having low frequency. When short waves fall on the retina, we get the sensation of blue. On the other hand, long waves give us the sensation of red. You see in this video, the small baby who has short steps has to take many steps in order to walk next to his mother that has long steps. The mother, being taller, takes few longer steps to cross the same distance that the baby has to do many short steps. This is the case with the blue short waves and the red long waves. The short waves will take so many steps to cross an area that the long waves will only cross it in few steps. So if there is a resistance, the resistance will be marked for this blue light and will be minimal for this red light. Now, the white light is formed of different components. The red one will meet little resistance, so it will be deviated but not much. On the other hand, the short waves will meet high resistance, so it will be deviated more and more. This will give us the spectrum of the 7 colors.